Hello, this is lesson 2 of the 14 lessons. First lesson we did was speed and velocity, where we saw that speed is a scalar number. It only has magnitude, a size to it, because distance is a scalar. When you quote a distance, you don't give the direction. If you give the direction, however, then you get what's called displacement, and that is an example of a vector number. And so that's why velocity is a vector. It contains an element of direction too. So today we're going to look at the acceleration equations. There's two of them. So I'm going to write them down first and then I'll explain each one. So acceleration is equal to the change in speed divided by the time taken to change. I'll just put time. So that's the first one. You will see it written out as A is equal to V minus U over T. I want to show you where that U comes from, because it's not immediately clear. So say we had a car, and the car at the beginning is not moving, so we can write a velocity of 0. And we start our stopwatch, so a time of 0 seconds, and we watch the car fly along. I can do this, which I like doing. Grab that. Left half the car. And the car moves along and it speeds up. So we get to a point where the velocity equals, let's keep it really simple, 6 meters per second. And the time that it's happened is now going let's keep it really easy, 3 seconds later. Whoops. So what we've got here is we have a change in velocity. We've gone from 0 to 6, and we have the time that it's taken for that change to happen. Now, where does this V minus U come from? Well, if I was to ask you what's the difference between 0 and 6, it's obvious. The change is 6 meters per second. But what have you done? Well, without even knowing it, you've done 6 minus 0. If this number was 2, you would do 6 minus 2. But there's a problem. In algebra, you can only have a letter for one number. But here we have two numbers for one number, for one letter. Let me get that right. So we go one back in the alphabet and we write a U. So how it looks now, if I rub this out and clean it up, how it looks now is 0. This letter we write as U because it means the initial velocity. So we write V minus U. V minus U equals, and we've got V is the end velocity. So we end up with 6 minus 0 equals 6. So it's a technicality. It really isn't that big a deal. We have acceleration is change in velocity, V minus U over T. Now it doesn't look like it, but you can put that in a triangle. So if I draw myself a triangle, try and get it neat, I can treat the V minus U as one number. So I can have V minus U at the top, A, T. And to remind you, to use a triangle, you cover up the one you want, say what you see. So in this case, V minus U over T. If I back up and I wanted to rearrange it to find the change in velocity, then I'd just cover up that. I would just take the acceleration and multiply it by the time. And final one, hopefully by now you're well ahead of me. If I wanted to know the time it took to make that change, if I knew the acceleration, then I would just divide V minus U over A. So let's have a look at it in action. So let's say we have a person and they're running. And we know that they have gone in a time of 4 seconds. They are running at 10 meters per second. And our question is, how fast were they running at the beginning? Might not be 0. if they're accelerating at 2 meters per second. A is 2 meters per second. So they're running along. We measure them over over 4 seconds of time. Every second they're getting faster by 2 meters per second, and their end velocity is 10 meters per second. So what we can do is we can substitute in. So we'll write A is equal to V, which is 10, minus, we don't know the U, over time, 4. And we can just rearrange this now. So we find that the answer was 2. So we end up with, answer was 2. We end up with taking the 4 up to the top. We multiply both sides by 4, which gives us 8. So we end up with 8 is equal to 10 minus something. So what must the something be? The something must have been 2 meters per second. So that's an example of about a level 6, level 7 question, finding the missing one. Most of the time you'll just be asked to put it into that equation. So that's the first one. The second one, the good news is you get given this equation in the exam sheet, and it's horrible to look at. It looks like this. V squared minus U squared equals 2AS. Yeah, yuck. Let's have a look at what each part means. So we have again the end velocity, we have the start velocity, we have obviously the number 2, we have the acceleration, and here we don't have speed, we have displacement. If you've seen my first video, you'll notice when I put down little s means displacement. Now, this one is is known as the constant acceleration equation. The constant acceleration equation. Where you'll see questions like this is one of two places. One is dropping things. So let's do example 1, e.g. 1, dropping a ball. So we take the ground, we take the ball, we'll make it a tennis ball. And the question is, how fast is the ball going to hit the ground? What is the velocity if we hold it a height, I can't spell height anymore, height of, say, 1.5 meters. Oh no, I haven't got a calculator with me. I'm going to make my life easier. 1 meter. So what do? Well, we first substitute in to our equation. So we have v squared, we don't know, minus u squared, which we do know, because u is the beginning velocity, and in this case you're holding a ball, so it's stationary, it's 0. So v squared minus 0 equals 2 times, now acceleration. What force is accelerating a ball down? Yes, I can hear you all shout out in unison. Gravity. Because gravity pulls everything down at 9.8 meters per second squared. Doesn't matter if it's heavy or if it's light, it's a constant. So 9.8 squared, 9.8 times the height that it was, because that is my displacement. So times 1. Now, I'm going to cheat. I'm going to change gravity to 10, just because I haven't got a calculator with me. And let's have a look what we get. So 2 times 10 times 1 is 20. So we have v squared equals 20. So I've panicked, and I've gone and got myself a calculator quick. And let's have a quick look at this. Calculator, there we go. Square root 20. 4.47. So V equals root 20, which is 4.47 meters per second. So that's the first example, dropping things. And obviously the higher up you drop it, the faster the ball will go. The other example you'll see are things like trains slowing down or speeding up. So they do like doing trains because they're a really nice example of a long deceleration or acceleration. So let's try this question. We've got ourselves a train. I can't draw trains. No concept. There we go. There we go. It's been a while since I've played around with trains. And we want to know if this train is already moving at a velocity, an initial velocity of, say, 50, something realistic. What might a train be moving at? Let's say 24 meters per second. And the brakes are applying a deceleration. So a deceleration is a negative acceleration. And let's say it's applying a deceleration of 1.4 meters per second squared. The question is, how far away does it need to put its brakes on to hit the stop? And at the stop point, my velocity, V, must equal 0, or else I've hit it. So let's substitute in the numbers again. We don't know the displacement, but we do know V squared equals 0. We know U squared equals 24 squared. I'll come back to that in a minute. We know the acceleration is minus 1.4. We know 2 is 2. And we don't know the displacement. We're going to find that out. So let's put it in. So we have 0 minus, again I get my calculator out, 24 times 24 is 576 equals 2 times 1.4, put a little minus in, times S. So now we've just got to tidy it up. We can immediately cancel out the naught, so we have minus 576. We can divide both sides by 2 times minus 1.4, which is 2.8. All I've done is divide by 2 times 1.4, like that, and I've just put it across the other side. And that gives me S. Final thing to do is divide them. So I have 576 divided by 2.8, and I get an answer of 205.7. 205.7 meters to stop in time. Okay, which sounds quite realistic if you think about it, possibly a bit further away. So that is the constant acceleration equation. So today we've covered both equations. You need to do practice on this. I'm going to post some questions for you to do. I'm going to post, it's called Physics, the Formula Bits. And all I want you to do is questions 1 to 4, but only A, B and C, and show completely how you did it. So as you do it, show that you're using V minus U over T. Get used to writing this stuff out. I'll also set some questions on the constant deceleration. Again, get used to using this and rearranging it. This one, kind of level 6, level 5. This one will get you up to level 7, level 8 quite happily. So there you go. Have a go at the questions. Take a photo of your notes or post a Google Doc at the end just to show you've done it. Thank you very much.